welcome everyone, and thanks for the introduction. So I can spare 1 minute out of it. So I'm Ádám, and I'm working at Nextent as Chief Architect. And basically today I would like to introduce our business for those who are probably not aware of this part of Nextent, and then guide you through some of the challenges that we faced and we have to think and consider during changing our applications. So basically, the IoT Energy business is part of one of the Nextent core businesses. So we are actually a separate solution provider, and this is a fully self-developed product. And also we have a self-developed hardware. So let's talk a little bit about our solution. So we call it EMS, Energy Management System. And some of large multinational companies already trusting our solution for their reporting and energy management needs. So basically, we have 3 different kind of use cases, what we actually covering. And one of them is basically the core EMS solution. And this is better suitable for large infrastructure. So for thousands of so-called pods. Basically, this is like those measurement units that the energy providers are giving you. It's giving for the companies as well, probably a little bit different sized, but it's the same concept. Also, it has a direct integration with our own IoT solution, and we'll get back to in a second. And also, it's much more suitable for a single big customer than the energy management system for energy audits. So that's targeting those companies that actually have mandate to be compliant with the Hungarian regulation. So the MEKH is the Hungarian Energy and Utilities Regulation Authority. And this is a multi-tenant solution. So now you probably wonder then what my presentation will be about if you already have a solution for that. It's suitable for multiple customers, considering even some of them that is mandated by this regulation. Is only have probably a few sites all over the country. But we actually separate their data, but also giving a full overview and obviously bulk capabilities for the audit company to work with it. And then our third solution is not related to the SCADA system that Siemens developed, but SCADA in this case is referring to supervisory control and data acquisition. So basically in this case, we actually have a complete remote control over these devices. So some of these devices installed was like probably decades ago, and they are using now not so modern technology for communication, but obviously because they wasn't cheap and obviously they are already established, so there is a need for that to be actually driven from remotely. And also some of these actions can be triggered by automatic interruption or based on some models that we develop. So some of the public companies that trust our solution is the Deutsche Telekom Group, including Hungarian Telecom Group, and the T-Systems Hungary, plus E.ON, and E2 is an energy audit company, which is part of the Met Group, which is a European company. So the EMS solution itself is a modern energy management system. So it's, as I mentioned, it supports measurement and data collection. Other than that, it also helps to monitor the infrastructure and visualize that data and actually helps to interrogate it by the users. So in this case, it supports the ISO and the energy audit processes and compliant with those regulations. And including in this kind of suite, it supports the energy desk officers' work and that helping them to make decisions based on data and actual facts, and also to intervene either manually through like a web interface or automatically. So Our solution also includes, as I mentioned, a self-developed hardware. So we call it Power Quality Analyzer. And this is not a single one, but multiple one, depending on the use case. So one of the benefits is that it's easy and interruption-free installation, which means that actually you don't have to disconnect those devices that is actually getting electricity from the network. You can install it without downtime. And because we looked around on the market, this is explicitly high accuracy measurements. So basically it's doing thousands of measurements and then aggregating it and then sending it to the software. And as I mentioned, we have multiple sizes and we support a couple of networking protocols. So by default, it's GSM, so it can be installed anywhere, a single device even, or it can use Wi-Fi or Ethernet as an internet connection, or it can use LoRa, which is a special technology for these kind of devices. Also, because it's not just for monitoring, it can also issue warnings, starting from like blackouts, including voltage changes, and basically many more, which is much suitable for those who actually deal with these hardwares. And also it's able to control, like, I don't know, open a window based on the humidity or temperature in the room. And to improve that, we have external sensor connectivity as well. So altogether, this is our solution, helps to be cost effective, time effective, and energy effective. So all of these three is basically giving the power to the software that we developed. Okay, so probably these numbers for some of you is a little bit small, but this is only coming from our devices. So currently we have a couple hundred installed, and we are at least planning for a 10-fold increase within a year. So currently we're storing only like 500,000 invoices. This is increasing like 20, 30,000 each month. And then we have these DSOs. So DSO is actually the utility company data. Usually they either providing within 50-minute or 1 hour measurements. And from our IoT devices, we are getting usually a minute interval data, but this is remotely configurable. So this is by default what they are sending. So to actually get to the topic of my presentation, I want to give a little bit overview that what technologies that we currently have in our stack. So basically, most of the infrastructure is running on Amazon Cloud. And this means that we are leveraging their RDS, so Relational Database System solution, and also we are leveraging Aurora for storing these data and the master data, obviously, for our customers. Other than that, the front end is powered by Angular, and the backend mostly written in Python, using, obviously, as you heard probably a few times already today, Docker containers in Kubernetes. And for the data visualization, we use ClickSense currently. So basically, this is we're quite confident that this is a flexible solution, but we are also seeing some scalability and how many customers we can serve. So basically, obviously, there is always some configuration step for each customer. So that's what we would like to a little bit shorten so we can meet with the demand that we are seeing from the market. So for those who are not fully aware that what is this single-tenant, multi-tenant thing, but actually jump to this presentation. So the single-tenant architecture that we are currently using, meaning that for individual customers, we are setting up basically their dedicated environment. So every application is using their own database. This is a very simplified schema. And probably there is an additional database which is actually storing that what kind of customers we are serving and what is their configuration values and things like that. So currently we need to set up for every customer their own system with their own infrastructure and their own cost, obviously. So the challenges in this case is actually have a cost-effective infrastructure scaling. So obviously, when you have a base requirement for your system, then it has to be always burdened in the implementation price. And then also the initial implementation, so the basic configuration, and the operational requirements for maintaining it as a software as a service solution. So basically, our customers only need to use it, and they don't have to deal with the underlying infrastructure, maintenance, patching, updating, and things like that. So to provide that, it obviously has some operational requirements from our side. And as I mentioned, we have a little bit 3 different systems. So basically, the underlying concept and the data model is very similar, but each need has a little bit different data that needs to be stored. So that obviously resulted in some deterioration. So basically, the business started last year, and we implemented these kind of solutions since that. However, with each need, we have to a little bit modify the object model and obviously need to create new code. So to standardize it, it's a little bit time-consuming, as even if you ever try to integrate multiple systems, you already know what I'm talking about. And also, as we are expanding rapidly, we see a data boom. So currently, as I mentioned, we receive a few billion measurements each month, but probably it will be 100 billion in a year or 2. And we doesn't even consider the dumb devices that our customers would like to connect and collect data from that, which is currently not possible for them. So to get back to the original topic, so the multi-tenant database is basically something that is serving, or multi-tenant application architecture is something that is serving multiple tenants. So in this case, you have like basically an application. In case of the customers, it would result in a kind of unified front end. And you have multiple databases separating completely their data. So you don't have to architecture so much for security considerations, because every data is basically partitioned by a separate database, so that would work out quite good. However, there is a different possibility for architecting multi-tenant databases. And basically, it's when you consider sharding. So sharding is basically a horizontal split in the data. So in this case, you actually architecturing for multiple customers in a single database. And if your application supports that, you can basically move each of them out. So you can basically have even-side databases while they are not seeing the data, and the application would handle all the additional details behind it. So basically, in our case, we are aiming for this with the so-called hybrid approach. So we would like to keep the possibility for individual customers have on their own dedicated databases in case of performance reason, data isolation, regulation, and so forth. So basically, this is what we are planning for, and this is what we designed our application. So what was the development goals when we started this whole process to be a little bit more agile on the market? So for ourselves, obviously, one of the important part is lower the cost, but even more than that, to lower the turnover and the requirements from man days, basically, how many days it needs to set up a new environment and configure it. And also, as I mentioned, as we have already 3 kind of different solutions, but all of them is aiming for the same goal. We would like to standardize the components and integrate it into a single system. So currently, the features can be turned on and turned off based on the demand, but it would be even better that any customer could benefit from these. And even most of these large single customer we have in the core system is having their own energy audit companies. So currently, we cannot handle multiple auditing companies in the same system. So now we are planning for that as well. And this would bring us the complete multi-tenancy. So you've seen that we have multi-tenant capabilities. This would add one more level with multiple auditing companies in one system. And as I mentioned, we have this data boom problem to adapt to the exponential growth of devices. And obviously, in some cases, we don't have to collect minute interval data, but even more frequent. That would increase, obviously, the data retention and the data storage needs for ourselves. And the edge computing. So I think that some of the presentation already mentioned this with fog computing and everything else. So edge computing in our case would mean that to connect these kind of dumb sensors in a secure way to our backend system, so we can actually collect the data from that and even remotely driven them or control them. So basically, these dumb devices using old protocols, which doesn't even heard about encryption and security, because they are used locally. So to connect them through internet, obviously need a secure solution for that. And one of the goals from our side was also to lower the infrastructure as a service element. So currently, ClickSense is running on root servers, which with Windows, which we installed and patching and keeping all the components up to date. So this would also reduce a little bit our operational needs and obviously having consideration for downtime and patching all the time. So the architectural objective that we kind of aim for is to have a couple of core modules which operate basically separately, and therefore, even in case of some failure, we can still serve our customers. So you can see in the right-hand side a very schematic overview of this. So the first part, obviously, the identity management. Identity management is obviously an important part because if you have the access, then you have the control. So we need to protect those resources that actually having access to this critical infrastructure. And to engineer for that, probably it's better to use an identity management provider in this case. And obviously, then we would have a web front end, what we have currently as well. And that would use only APIs with validated tokens at the backend. And that would connect all the subsystems with the front end. So basically, in our case, the SQL database, which would store the master data, and the data lake and the NoSQL data stores as well. And obviously have the remote management capabilities, and the BI tool should collect all the information from these data sources. So with this, we are aiming to eliminate all the root servers and virtual machines that we are currently running. And as I mentioned, the complete multi-tenancy was a very important goal, and also to have open APIs for integration. So obviously with our multinational company partners, there is a need to actually programmatically access and securely access those resources where we are storing their data, and actually able them to verify and even upload some of these parts, and auto-scaling of these resources. So the auto-scaling brings us to the scalability issues that we are facing. So obviously, depending on if you introduce a new customer, your customers you already have is buying new devices, or you actually just keeping their data and cannot even attract new ones, then you have to consider for different level of scaling. So if you split up the different components, then you can cost efficiently scale and to the actual needs that you are facing. So if you need to store more data or you have to handle more customers, you can engineer on that from the database side. Also, to have a scalable system, you need to share or you need to have shared or isolated resources. So in case of shared resources, you obviously have to monitor for their performance, but most of the cases, most of the users doesn't use any system. And this is especially true for this kind of reporting system where you obviously, people are interacting it when they have something to actually extract, look at, visualize, or control. So this have to be considered. And load leveling. So basically, in every case, most of the companies facing with peak demands in like regular intervals. I don't know, like probably the Hungarian tax authority is now facing a little bit peak demand for the personal income submission, because this is the last few days. So obviously we need to engineer for load leveling, and there is a different concepts for this, and I will get back to that on the next slide. And obviously by integrating and sharing some of these resources, then you can actually lower the operational complexity. And obviously, if you reduce the complexity, then you reduce the amount of resources that you need for that as well. So what kind of challenges you face when you need to architecture for this? So obviously for uptime and resiliency, you have a few options. I'm not saying that we don't use already some of these. I'm just saying that if you are planning to do something that actually is a software as a service solution, that you probably need to think about all of these things. So like geo-redundancy, basically you copy-paste your full infrastructure in a different region, different data center, something like that. And with some other magical changes, it will fail over in case of there is a downtime. And obviously, you can use clustering and self-healing, like in case of this containerized solution, there is a self-healing capability, and obviously you cluster all your critical system to actually engineer for a node downtime, if a node has to be patched or something like that. And if you read ahead, then you see that caching is twice. It's not a mistake. So obviously, resiliency can be supported by caching. So if your data warehouse or data store somehow is experiencing some intermittent connectivity issues or actual downtime, then caching could help to basically, even if it's a stale data for a few minutes or a few seconds, but it's still giving a response for the user. So that would help the resiliency efforts. And obviously, you should always have a disaster recovery plan and a solution how you can do that and what is your time to actually recover from a critical incident. On the performance side, you need to consider for auto-scaling, as I mentioned, load balancing, obviously, when you have clusters and different systems is a no-brainer, and caching as well. Caching usually like Redis cache or something like that is helping to actually lower the database load in case of recurring request. And CQRS. CQRS, for those who probably never heard this, is command and query responsibility segregation. This is a kind of data access strategy. So in this case, in case of like database operations, the read and the rest of the create, update, and delete operations are separated into like queues or a different even database, or you have some cached material or indexed views for read, and that would refresh by the updates. And you can use this for also load leveling. So all these update, create, and delete requests would go into a queue, and then the database only picks it up when it has free resources. So when we think about reengineering our architecture, we try to find all those components that would actually serve from what we learned in the last 1.5 years from our project. So obviously, some of the maintenance task and time-based triggers can be, and also some of the APIs can be leverage a serverless component, which is also very trendy nowadays. So in the case of Azure, it could be functions. And for complete, for the hybrid sharded multi-tenant database structure, when you can actually isolate resources and even give them a different kind of physical resource, but they would still act as a single kind of unit from the programming perspective, we can use Azure SQL Elastic Pools. For the NoSQL parts, for the nearby data in time, at least, we would use Cosmos DB. And for the long-term retention, archiving capabilities, the data lakes, so basically Hadoop. We would still keep the Kubernetes because that would that's a very good architecture, I believe. And we could also use it to eliminate some of the virtual machines that we otherwise need to use. And for load leveling and other use cases, Service Bus is a consumable, and you can subscribe and publish to different topics. So it's suitable for multiple use cases. On the remote capabilities, Apache NiFi is a open source software which help us to create edge computing infrastructure and to actually securely connect and collect data from remote locations. And we are also planning to replace Qlik with a new BI solution, but still in the making. So probably next year I can talk about that. And overall, if we consider all of this, we can have a scalable system with on all of the components at least 3 nines uptime. And in most cases, then it can be achieved 4 nines. So basically, 4 nines means 30-something minutes every year for a downtime. Also, in this case, we have the 3 little bit different systems integrated, and we would have the dump sensor connectivity. So basically, already established infrastructure can be leveraged as a cost-effective manner. So it would help us and our customers to ensure a cost-effective infrastructure management solution, which can cover all of their use cases. So with this, thanks for your attention. And if you have any questions, I'm happy to answer that.
So thank you very much, Ádám. Please applause for the presenter. It was a great presentation. And do you have any questions right now, right here? Nope. All right. Then I have a question. And what do you think? Which one from the mentioned technologies is the most cost-effective to change the BI part, the database part, the cloud part, or whatever?
I think overall the database part is the most important. Obviously, because we are to store the data and to create a web application, everybody can do that. But actually, we are not doing just that. We are creating value from the data. So basically, what our solution offers is not just storing the data, but actually giving insight and giving business benefit and cost saving from that. So if you are planning to leverage the data, then you need to have a good data solution. That's the most important part. And doing that for the right way.
Okay, thank you very much.